Welcome to this demonstration of static fatigue analysis using Autodesk Nastran In-CAD. During this video, we'll discuss the life of the fork crown for the bicycle suspension. Where are the high stress concentrations? And how many load cycles will it handle before cracks begin to form? For the purpose of this analysis, we only need to focus our attention on the fork and hide the other components. Let's begin by setting up a linear static study to analyze this baseline design. We can use the material directly from the CAD model or choose a different model from the Autodesk library. Here, we will also specify the part we're going to analyze and confirm the material and type of elements we're going to use. For the boundary conditions, we will constrain the two holes that are tightened down to the rod for each strut. Then we will apply a large force to the center hole. We will then mesh the parts with solid elements and run a static analysis. Following the analysis, we can look at the von Mises stress to determine if we have any areas of concern. We can see that the highest stress in our model is 37 megapascals. That is low enough that we can make the changes to the design that would provide a lighter component for the bike. We can open up the part right inside Autodesk Inventor and change the dimensions of the crown. After updating the part, use Autodesk Nastran In-CAD to update the mesh and rerun the analysis all in the same CAD environment. Back in the stress plot, we can see that the stress values have increased as expected. The question now is, how long would the part last? We know that 139 megapascals is past the endurance limit of aluminum. Let's change the study type. There are two fatigue options for static loads, as well as fatigue based on a random vibration analysis. We will pick multi-axial fatigue for this scenario. There are a few changes we make to the setup, starting with the material information. Enter known material fatigue information such as slope, limit stress, and the corresponding number of cycles and the endurance limit after that value, which is often close to 0. We'll take a look at the chart to assure that the results we entered visually look correct. We can now look at the life plot and find out how many 5,000 Newton loads the fork crown will handle before cracks begin to form and ultimately cause the part to break. We can see here that the number of load cycles is 322,000, with a very large applied load. We can consider the part to be safe for normal use. Remember that changes are made right here in Inventor. We may decide to change the model several times for a better design. As you have seen, this analysis solves in less than a minute. Oftentimes, there is no need to leave your desk to wait for the results. Autodesk Nastran In-CAD provides powerful digital prototyping technology, saving time and money for innovations on your designs.